Now let's talk about classes. When we build a class, we are building a blueprint for an object. We want our object to have certain parameters. A class establishes and is a relationship with the objects. For example, a shark is a fish. A zoo shark is a shark, and a zoo shark is a fish. So an object is a concrete example of the class. We can have classes and subclasses, an overarching fish class, an underarching shark class, and a zoo shark class, which is a shark. But the implementation, the final object that's been created, is the actual instantiation, the bringing into the world of our blueprint, which is the class. It's reusable. I can call the fish class to instantiate a shark. I can call the fish class to instantiate a flounder. I can call the fish class to instantiate a salmon. And methods are often called upon within the object to return a piece of information to the source of the request. There's a class client and a class user. The class user uses that class to handle its affairs, and the class client is within the class using the class. So effectively, the application or class that instantiates the objects of another pre-written class are the client or user of that class. When creating a class, we assign a name to the class, we determine what data and methods will be part of the class, and we create a class header with 3 parts. An optional access modifier, so like we've been saying, public class so far, the keyword class, and the legal identifier name of the class. A public class is accessible by all objects. And here's an example of a class with 1 field. Let's check that out in code. Okay, so fairly straightforward. I just wanted to mention that I've created a employee class here, and it has 1 attribute, the emp number. And we're going to play a little more with this later, but I wanted to show it to you in the coding window. And I wanted you also to know if you were to run this code by itself. So I'm going to go ahead and compile. It will compile. When you try to run it, it's going to give you an error. Let me show that to you. It's going to say that there's no main class, because there isn't. We need a main class in order to instantiate this object. Alright, so there are things that you can use. You can extend another class, and that gives you a basis for a different class. You can use data fields. The variables can be declared within a class, but outside of a method. So you can see that we created a class with an employee number that was independent of any method. And you can create an instance variable. These variables are, actually these are the same variables that you create outside the method, but these are non-static fields, and every object will have the same fields. So if you have like employee number, every employee will have a number that's uniquely assigned to that employee. All right. You generally have private access for fields so that no other class can access the field's values, and only methods of the same class are allowed to use these private variables. You can grant access to it by using get or set methods. This allows you to hide information. Now, most class methods are public because people can use those class methods outside of the class. There's a couple of methods that you need to know about. There are mutator methods where you can set or change field values. There's accessor methods, and these retrieve values. And then there's non-static methods. We just don't put the static keyword. And these are behaviors that belong to objects. So like you might have like bounce for a ball. The bounce method belongs to the ball. we typically declare non-static data fields, right? So that means those data fields are declared within the header of the method. And static class variables. So if you were to say like a static variable within a method header, that means they're not instance variables. They're shared among the entire class. So you might have like the shop rate for a labor in a workforce that is a static variable. Every labor in that workforce is going to have the same number, and each individual person doesn't have that instance. So you might have like a max pay, or maybe you have like how much the total hours are of all your equipment. You'll have a static variable that handles that, that's independent of the instance. All right, and I want to compare static and non-static real quick. In Java, static's a keyword. It can also be used as an adjective. Static fields in a class are called class fields because they go across the class and not just by the instance. Static methods are called class methods because they're once again used across the class. When you use a static field or method, you do not use an object. For example, goption_pane.showDialog. ShowDialog is a static method and does not need an object. When you create a class with a static field and instantiate 100 objects, only one copy of the static field exists in memory because all of the objects share that static field. When you create a static method, the same thing happens. Only one copy of that method exists because all the objects share that method. Static class variables are not instance variables. The system allocates memory to whole class variables once per class, no matter how many objects you create. The system allocates memory for class variables the first time it encounters a class, and every object shares that same copy. In non-static methods, there's no keyword for non-static. You just leave the word static off. Non-static fields are called instance variables because they're owned by the object, so every instance has its own variable. Non-static methods in a class are called instance methods. When you use a non-static field or method, you must use an object. For example, system.out.print. Out is the object that holds that print line method. When you create a class with a non-static field and instantiate 100 objects, then 100 copies of that field exist in memory because every object has a different value for that field. Same thing with objects. When you have a method and it's non-static, every object will have its own method that's been created because it may have a method in a different state than another object. Either way, that method is created for every one of the objects. Instance fields and methods are non-static. The system allocates a separate memory location for each non-static field in each instance. Let's show some examples of legal and illegal method calls based on combination of method modifiers. Okay, this is the class, public class, my class, with a static pub_stat stat method, a static private stat method, a non-static pub non-stat method, and a private non-stat method. Okay, so in the first case, object.pub non-stat method, the public non-static method can be used from test class with a my class object. Object.pubStatic method, the public static method can be used from test class with or without an object. And finally, my class.pubStat method will work because it does not have an object, but it still works because the method is static. None of the following will work. My class.privStat method, you don't have access to a private method. Its access is secured only within the class. My class.pub non-stat method, the non-static method must be used with a my class object. So effectively, you can't use the non-stat method because you're calling the class. Hold on. Oops. Object.privstat method, in this case you can't access it because these methods are private. They can't be used here. And now we have myClass.priv non-stat method. This is wrong on 2 counts. The method is non-static, so it needs an object. And in any event, the method is private. Alright, so now we have the employee class with 1 field and 2 methods. Let's jump into the code and look at this. Okay, so here's our method in code. And I'm going to go ahead and show you how this runs by typing in a couple of things here. You don't have to necessarily do this, I don't think, for any of your homework. But I am going to, I've created a package out of employee. So I'm going to go ahead and use that package in the pay calculations method. And we're going to see how this looks. So you'll see how I've created a new employee, right? And what I want to do is I want to set the employee number. So employee 1 dot set, what did I say here? Set imp number, and we're just gonna make it 1112, right? And I'm gonna take this here and put this here. So now we should have well, what you'll notice first, let me go and run this code without this because I wanted to show this to you first. Alright, so I'm going to go ahead and save pay calculations real quick. Let me go and save it here. And I'm going to run it. Alright, so it says imp number has private access, and that's exactly right. This is private access, so we can't access it. But I've created a public class where I can get the employee number. So I'm going to go back in here and I'm going to, instead of saying imp number, I'm going to say get employee number like this. That calls this method or that method, and it should return the employee number. Now we're going to set the employee number, and we're going to get the employee number again. So I'm going to set this properly, get employee number. I'm going to save this code, and I'm going to jump on this side and go ahead and run this. And then now it compiles because we now have a private method issue, and I'm going to run it again, and we have employee number is 0 and employee number is 1122. Couple of things. When I first created the employee, it created an employee with an employee number of 0. Then I could set the employee number, and you could see this method here. When I set the employee number, then it showed up as 1122. But this is how these methods work. This just returns what's here, sends this back out to memory, and this sets the employee number, sets this variable to what I pass into the parameter list. So of course that's what it looks like here. And when you're creating methods like this, you need to make sure that you do a couple of things. One, that you place data fields in logical order at the beginning of the class and list the fields vertically. Data fields and methods may be placed in any order within a class, but it's common to list all the data fields first. Names and data types can be seen before reading the methods that use the data field, and that's why we put them all at the top of the class. Okay, so let's look at what's happening here. we have our public class employee, and we've added some additional attributes to an employee. We've added first name and last name and salary. Then we can add methods below it. So what I've done in my code is I've typed in the entire class with all the 4 mentioned data types, but I've also created accessors and modifiers, or accessors and mutators for every one of the data types. So the accessor simply returns what's being asked for, and the setter sets that particular thing. So in the case of like set first name and set last name, you can see that the last name and first name are changed to whatever name we passed in. Let me go ahead and save and compile and save everything right now, and we can see how that looks. I'm going to go ahead and compile that package. Then we are going to come back to pay calculations for now. And you can see that, let me see, the employee number for EMP1 dot get first name is that. And I'm going to go ahead and employee1 dot set first name. We're going to call this employee Chad. And I'm going to say the employee number for employee1 dot get first name is that. Let's go ahead and change this here. I don't know why I said first name. Okay, so there we go. I'm gonna go ahead and save this real quick, and then we're gonna run it. I may have made an error, and that's okay. We'll talk about it if I did. Alright, someone in Java C. Alright, so I, of course, did not put a plus here. And let me go ahead and put a plus there. And then that should maybe work. So I'm going to save this and go ahead and run this. Pay calculations .java error cannot find symbol. It's telling me that get first name it can't find. That's because I didn't make this a method call with the parentheses. Let's see, that's the best I can do. Hold on. There it is. We'll do the same thing here. Gotta put those parentheses there for this to work effectively. So let's go ahead and save that. And then come back over here. We're gonna clear the screen. I'm gonna go ahead and try to do it now. Alright. Man, I don't know why I'm having so many errors tonight. Employee1 dot set first name for Chad. Says get first name. Did I not save this? Let's see if I can save it again and see what I can do. Alright. Let's see. Alright. Get first name. Oh, get employee first name. You can see get employee first name instead of get first name. So we're going to go ahead and make that work. Get employee first name. Let's type that in correctly. Get employee first name. And then get employee first name. Control S. Okay. Let's make sure that I'm... once again, I have to save. No, I don't have to say that. methods here. I'm gonna go and run this, and it's telling me that I have a problem with private access because I created private getters. Private getters don't work. So I need to go ahead and change these. Why would I have typed in private? I'm gonna go ahead and change these to public getters and setters, which is what they should have been to begin with. Alright, public getters and setters. I'm gonna just real quickly copy and paste over each one of these. And yes. Alright, Control S, come back over here, CLS. I'm gonna go ahead and do that. And then I should be able to run my pay calculations. Employee 1 dot set first name Chad. That's because under my pay calculations it should have been set EMP first name. Instead of that, let's do this again. Alright, finally got it. Okay, and you can see that it works. So it says null because when I create a numerical number, the value is 0. But if I create a primitive data type, it's going to give us a 0 value. If I create a reference data type, it's going to give us a null value. So it was null until we passed in a name, and then the name was functional. Okay, so you can see what it looks like here. This is the employee name and number and all the methods that we use, which is the accessors and mutators. And you can see how that looks. We are going to stop the recording here.